Welcome back to part 4. Now here we're going to look at some math, some things that we'd like to do with correlations that SPSS won't do for us, so we need to do them by hand. Thankfully, the math isn't that hard, but it does require due diligence. So we're going to look at a very simple data set here, and this is actually the example used in the textbook. And here, let me move this because we're missing one data point. Okay, so here we're looking at the relationship between the number of advertisements that a participant saw for a particular, I think it was candy, and then the number of packets of candy that they bought. And this is, because we're doing some math by hand here, we don't want to have a lot of data, so we're just going to look at these 5 data points. So for example, if we look over at 5 adverts, if we look up, we can see there's one circle there. So this participant saw 5 advertisements, and it looks like they bought 8 packets of candy. So we're going to be using those values in these calculations. So first of all, let's talk about covariance, the idea of two variables varying together, which is in essence what we're looking at with a correlation. We're looking at the variance between two variables and how commonly they covary. So covariance conceptually, what we can think about is we have these two variables, advertisements shown here in blue, and the number of packets. Now those horizontal lines, those are the means across the 5 participants. So the number of packets purchased looks to be about 11, and for our first participant, they were 3 packets below that mean. So they're varying below the grand mean in this case. Participant 5, they're varying in the opposite direction. They purchased 4 more packets than the grand mean. And we can look at a similar relationship for the number of adverts. And what we can do is we can look at whether the variability from the grand means in these two variables covary. As you purchase less packets, does that also covary with seeing less advertisements? And here it looks like there is a linear relationship between this covariation, which is a correlation. So if you look at the last participant, they're way above the mean, both in advertisements and in packets. So they are covarying in the same direction. So how do we calculate variance? So instead of talking about covariance first, let's just talk about variance. And we've seen the calculation for variance before. So variance is denoted S squared. Just S would be your standard deviation. So you are summing across, you take every value, subtract the mean. Now we're going to square those values, because remember, if we don't square them, the positive and negatives all cancel out. So we square them so that they're all positive and they don't cancel each other out. And we divide by the degrees of freedom, which in this case is n minus 1. So if we look at that for one of these variables, trying to remember whether this is packets or adverts. Let's go forward one slide. Okay, it's adverts. Okay, my apologies. So here we've got adverts. So our first participant, they saw 5 adverts. The grand mean was 5.4 adverts, so we have to subtract those and then square them. And then we're going to do that for the remaining 5 participants, and we divide by 5 minus 1, 5 being the number of participants, so 4 degrees of freedom. So if we work this out, you'll find that the variance is 2.8. That's the amount of variability there is to the number of adverts. If we take the square root of S squared, we get S, which is our standard deviation. We'll see this reappear later. In this case, it's 1.6733. So we can calculate variance for adverts. We can also calculate the amount of variation there were to the number of packets purchased. And here I haven't done the whole equation, but if we work it out, we see that the variance in the number of packets is a bit larger. It's 8.5. If we take the square root of that to get the standard deviation, or S, it's 2.9155. So that's variance. So how do we go from variance to covariance? And covariance is what we need to calculate a correlation. So if we look at the variance formula, remember that we take the mean value we take an individual value, subtract the mean, and square it. The reason we square it is that so that positives and negatives don't cancel out. Let's think about that a little bit differently. Let's redraw this formula so it doesn't have, it's still squared, but we draw what's in the brackets twice. So this is the same as squaring it, but here we've drawn it out twice in a row. So we take the mean, we take a value, subtract the mean, we multiply that by that same value, subtract the mean, and that gives us our variance. Well, covariance is a simple change to this formula. What we do is instead of squaring it, we have a value, subtract its mean, and we're going to multiply that by our other variable. So we take the value, if this first one is adverts, the second one is packets, we take the participant's value for packets, subtract the mean, and then we're going to multiply these together. What this kind of simple change does is now instead of talking about the amount of variance in one variable, we're going to see the amount of covariance between two variables. And just like before, we'll divide this by our degrees of freedom, which is still n minus 1. So if we work this out in the first case, so I've already done those subtractions. So the difference between adverts and the grand mean of adverts for participant 1 was negative 0.4. And the difference between the packets, their packets, and the number of average packets was negative 3. So we have to multiply these values. We do that for each participant. We divide that by 4. And in this case, we get a covariance of 4.25. Now that is not our correlation coefficient. The problem with covariance is that it will depend on, its magnitude will depend on the number of participants. So think about if instead of having 5 participants, we had 10 participants, then the numerator of this equation, instead of adding 5 things together, we'd be adding 10 things together, and the covariance would likely be larger. So what we need to do is find a way to normalize this based on the number of measurements. And the way we do that is we divide by the standard deviation. And we actually, because we're talking about two variables, we multiply the standard deviation in our first variable by our second variable. And this actually gives us our correlation coefficient. And it is literally the covariance divided by the multiplication of our two standard deviations, which mathematicians consider a standardized version of the covariance. It will account for the number of participants we have in our data set. So if we look at this last example, this simple example is just 5 participants. The covariance was 4.25, and then we need to multiply that by the standard deviation of our two variables, which we previously saw was the square root of the variance. And we do this, and in this case, we get a correlation has a large effect size. The coefficient of determination is 0.8715. So we have a positive relationship. The more packets, well, the more adverts, the more packets, and the effect size here is large, and we could probably even say very large. How do we calculate whether our correlation is significantly different from 0 or from no correlation? Now we saw SPSS does do this for us, but I want to show you how to do this by hand, because when we get to the last part of this class, some of these concepts will transfer from this calculation to those. So for our calculation of whether it's significant, we are basically calculating a t-value, so similar to a t-test. And here the formula, I've put a sub r just to remind us that we're still using a t-value from a t-table, but it's coming from this correlation formula. So we take our correlation coefficient r, we multiply it by the square root of n, the number of participants, minus 2, and we divide that by the square root of 1 minus the correlation coefficient squared. So if we do it for this example with just 5 participants, so our r value was 0.8715, the number of participants was 5. We do a little bit of math here. and we should find, oh, gonna have to move this, that our t-value here is 3.0871. Now the question is, okay, well, is this significantly different from no correlation? And what we need to do is look up our critical t-value based on this many degrees of freedom. So we found a t-value of 3.0781. The degrees of freedom for a correlation, they're actually n minus 2. So we had 5 participants minus 2 is 3 degrees of freedom. And we go to a t-table. So we saw these previously in t-tests. And we have 3 degrees of freedom. So we're going to be looking along this row. And then we want to do a two-tailed test. So we're looking when our two tails is equal to 0.05 or when one tail is equal to 0.025. So we want to look at this column. And where they intersect, this value here, 3.182, that's the critical value we're comparing our t-value to. And if our t-value is equal or larger, then we have a significant difference at a p-value of 0.05. Here, our t-value, t sub r, is about 3.08. The critical value is larger than that. It's about 3.18. So we have a non-significant difference. Now using MATLAB, you can actually calculate the exact p-value. And because our t-value was close to the critical t-value, it was actually quite close, our p-value is also close to 0.05. It's 0.0542. I won't ask you to calculate p-values in MATLAB. I just wanted to show you that it is possible. Okay, so our math should be identical to what SPSS does for us. So let's compare our results to SPSS. So remember when we did this by hand, the correlation we found when we standardized the covariance, the correlation coefficient was 0.8715, and our p-value, thanks to some help from MATLAB, was 0.0542. Here are the results from SPSS. And we'll just jump down to the correlation here, and sure enough, look, our correlation coefficient is 0.871. That is about the same as what we got, with probably just some differences in rounding. And the p-value, our p-value is 0.0542, and from SPSS is 0.054. So the math that I just showed you should be exactly the same math that SPSS is doing. The reason we went through that is because that is going to pay dividends when we do some other calculations. It just helped to introduce this first. So that's the end of part 4, and I'll see you in our last part, number 5.